Hello, so we're going to be looking at topic 6, groups of the periodic table. We're going to focus on group 1 for this video. There'll be other videos for group 7 and group 0. So while you're watching this, make sure you're not on your mobile phone, you are paying attention and have a pen and paper ready to take notes, and there will be an exam question at the end to have a go at. But if you're ready, we will begin. So we're going to look at group 1, which are known as the alkali metals. Now the alkali metals are these ones all here. They're in group 1 of the periodic table. They've got the 1 at the top of it. And they have some things that are all in common. So they're known as the alkali metals. Chances are there will be a question in your exam asking you to name one of the groups, and group 1 is known as the alkali metals. So group 1, first letter of the alphabet is A, so it is the alkali metals. Now they all have similar properties. You think back to when you learnt about the periodic table, you'll know that Mendeleev put the elements into groups of similar properties. So how they behave, different things that they do, and they're all in group 1 for this one. Now, because they're all in group 1, they all have 1 electron in their outer shell. Very helpfully, the periodic table at the top tells us how many electrons are in the outer shell of each one. The group number matches up to that. So all of group 1 have 1 electron. All of group 2, and these ones here, have 2 electrons. All of group 3 have 3. Group 4 have 4. Group 5 have 5 electrons, and so forth. Group 0, and they have a full outer shell or no electrons. And they all form 1 plus ions. So hopefully you remember that an ion is an atom that has lost or gained electrons to get a full outer shell. Now they've all lost 1 electron, so they have 1 plus ions. If you think about it, they've given away an electron. If you're adding something, they're going to have a 1 plus ion. That bit always feels a bit backwards, but our metals will always form positives, and non-metals will be negatives. But we can remember our group 1 form 1 plus ions. So they're known as the alkali metals. They all have similar properties. They have 1 electron in their outer shell, and they all form 1 plus ions. Now we've got 2 properties, or 2 further properties we want to have a look at. And that is they are soft, so they are metals, but they are very, very soft. What I mean by they're soft is that you can cut them with a knife. So you can cut with a knife. And that's relatively easily. And they have relatively low melting points. Now that is a low melting point for a metal. And we're not talking about you can hold it and it's going to melt. But we're talking sort of less than 100 degrees and we can get them to melt. They are relatively low. Now our reason why for this is to do with the bonding. They have something called metallic bonding. So we have 3 types of bonding: ionic, covalent and metallic bonding. With our metallic bonding, we've got our atoms. So we're going to have it as a solid. I'm going to draw little gaps in between them because there are, in fact, gaps in between them. And we've got our metal ions. They all form ions. So when they're all bonded together, they lose their outer shell electron. And they have a 1 plus charge. Now, in between these, we've got our electrons. These electrons here that they've lost are known as our sea of delocalized electrons. So they are a sea of delocalized electrons. So we've got a sea of delocalized electrons. Now what we have positive ions and negative electrons. So we get a force of attraction between them. So we have this force of attraction between them that is holding them in shape. So we've got, and if we're being really, really pernickety, it is an electrostatic force of attraction. Now, because we only have one electron and one ion, or our ratio is 1 to 1, and 1 plus ion, attraction is relatively weak. It's relatively weak compared to other metals. So this is weak compared to other metals. So it is weak compared to other metals, which is why they have relatively low melting points. They are soft as well, so we can break that force of attraction relatively easily with a knife. They're soft and relatively low melting points. So let's take a look at how they react with water. We'll look at the word equations first. Now, our general equation is alkali metal plus water makes a metal hydroxide plus hydrogen. And with that, I've got an example here. I've got lithium plus water makes lithium hydroxide plus hydrogen. It's very rare they'll ask you just to write the word equation. You also have to write the balanced symbol equation as well, including state symbols. So we've got it there for lithium. So I've made sure that it is balanced. So we've got the 2's in front of these. There's no 2 in front of my hydrogen. And this gives us the balanced equation. I've got my state symbols. I've got solid, liquid, gas, and aqueous. Aqueous meaning dissolved in water. And we can see what's going on. Now, our OH here, which is the hydroxide ion, is an OH minus ion. This is what makes an alkali solution. So this makes a solution alkaline. If we see an OH somewhere, we know we've probably got an alkaline solution. So we've got these here. What I've got for you now are sodium and water and potassium and water. Have a go at trying to write the word equation and the balanced symbol equation for these. Pause the video and then play when you are ready. So you should now only be watching if you have written the equations. Let's have a look and see if you got them right. So for sodium and water, we make sodium hydroxide plus hydrogen. And we've got our balanced symbol equation there. So 2Na plus 2H2O makes 2NaOH plus H2. Well done if you got that one right. And then we've got potassium plus water will make potassium hydroxide and hydrogen. And then our symbol equation is 2K plus 2H2O makes 2KOH plus H2. Well done if you got both of those right. You're doing brilliantly. So let's have a look at how they react with water. So we're going to look at lithium first. So I'm going to put Li down here. So if I have a chunk of lithium and I put it into water, it's going to float because it has a low density, and it's going to fizz or effervesce. So it's going to give off a gas. That gas is hydrogen. So that gas is hydrogen. It's going to fizz or effervesce and eventually disappear. So it's then going to disappear and we will be left with nothing in there apart from an alkaline solution. Our next one we've got is sodium. So we'll write Na for sodium. If I drop some sodium in, again, it's going to effervesce. So we're going to get our hydrogen gas. It's going to fizz a lot quicker than the lithium one. And rather strangely, with sodium, instead of staying as a square or whatever shape we cut it into, it very quickly turns into a ball. It turns into a round shape and whizzes around the container. And again, eventually, it disappears. It's gone, it's completely reacted, and we're left with our sodium hydroxide. Our final one we've got is potassium. So we've got K. Now potassium is a lot more exciting. we drop our potassium in, again we get that fizzing, we get that hydrogen gas coming off, but we also see a lilac flame. So we get a lilac flame that will appear. And this is because the reaction has happened so quickly, our temperature's increased, we've managed to ignite some of the hydrogen and it burns with the potassium, forming a lilac flame. And again, it will disappear. It's then all completely reacted. Now there are ones further down. We've got rubidium, cesium, francium that are also in group 1. We can't drop those in water at school because it's far too dangerous. As you've seen, they get more and more reactive as we go down the group. If we were to drop rubidium in there, chances are it would still fizz, but it would also catch fire and probably explode. Cesium would definitely explode, and francium, there's not enough of it in the world for us to do it because it's so highly reactive and radioactive, it doesn't exist for long enough, but it would cause a huge explosion. So that as we go down, they become more reactive. They also get more expensive and we get bigger reactions. But all the reactions are similar. We get fizzing, we get effervescence, and we get hydrogen gas produced. So our explanation for this will be on this part of the video. So we've got there, I've drawn out the lithium, sodium and potassium atoms as electron shell diagrams. I've shown all the shells. You can see they've all got 2 in the first shell and 1 in the outer shell. Any in the middle that need to be filled in, I've got 8 in. Now our reason for why they get more reactive and our reactivity increases going down the group is because our atomic radius increases. Now our atomic radius is this distance here. It's the distance from the nucleus to the outer shell. We can see it's getting bigger. If I did the next one, so rubidium, it would be even larger. And that means the outer shell electron is further from the nucleus. Now, because it's further from the nucleus, there is a weaker force of attraction between the nucleus and the outer shell electron, because we have a positive nucleus, we're positive in the middle, and we are negative on the outside. So we've got different charges and they will attract. So a positive nucleus will attract a negative electron. So they are holding them in place. But as we get further out, that force of attraction becomes weaker. Because that force of attraction is weaker, it is easier to lose the outer shell electron to form a +1 ion. And that is how our metals react. They form ions when they react. So the easier it is to form an ion, the more reactive it is. So we've got our kind of 4 statements there for what's going on. Our atomic radius increases, outer shell electron is further from the nucleus, weaker force of attraction between the nucleus and the outer shell electron, and then it's easier to lose that outer shell electron to form a 1+ ion. That is our explanation for it. Now, there may be questions where the terms are varied slightly. You can explain where one is more reactive than another, or they may even ask you about group 2 to really stretch you. The principle is exactly the same. So we're now going to have a look at 2 exam questions. So these are from a past paper. Have a go at trying to answer them. So please pause the video now. So you should now only be watching if you have answered both of those questions and give it a good go. So these are the answers. So for part 1, we're going to see some effervescence or bubbling. That's the hydrogen gas being produced. Our piece of rubidium will get smaller and disappear. And the piece of rubidium will also explode or catch fire. Either one of those is fine. You need 2 of these points to get both the marks, so make sure you've got at least 2 of them. Our second question is asking about that reactivity. So our answer is lithium has a smaller atomic radius than potassium. The outer shell in lithium is closer to the nucleus than in potassium. So there is a stronger electrostatic force of attraction between the nucleus and the outer shell electron in a lithium atom than in a potassium atom. So therefore it is harder for lithium to lose an electron and form a 1+ ion than potassium. Again, I've put 4 points there. You only kind of need 3 of them. The first 2 points are broadly the same, but I've put them in so we can see how we can get there. Well done for making it through this video, especially if you managed to answer all of the questions right, and good luck with your exams. Next video will be looking at the group 7 halogens. Take care. Bye-bye.